Alright, we're going to investigate logarithms a little bit here and figure out what sorts of restrictions there may be on them. So let's begin by asking something like log base 2 of 8. Log base 2 of 8 means what power do you raise 2 to get 8? 2 to what power equals 8? And the answer to that, of course, is 3. So no problem there. Now, let's look at log base 2 of negative 8. This means 2 to what power equals negative 8? Well, you should start to think that if you raise 2 to a positive power, or, well, let's say this, 2 to the first power is 2, of course. So 2 to a higher power is going to be bigger than 2. So the exponent here can't be bigger than 1 if you want to get a negative 8. So it has to be less than 1. So let's look at 2 to the 0 power. 2 to the 0 power is just 1. Anything to the 0 is just 1. So that's still not small enough. So we need to make the exponent even smaller. So let's make it negative 2. 2 to the negative 2 power means, well, 2 squared is 4. So 2 to the negative 2 is the reciprocal of that, 1/4. So that's still not small enough. So let's make the exponent even smaller. 2 to the negative 10. 2 to the 10th power is 1024. So 2 to the negative 10 power is 1 over 1024. So I hope you can see that as the exponents get more and more negative, the value gets smaller and smaller. And in fact, it's not even ever going to reach 0 or lower. So that means that you're never going to be able to raise 2 to a power to reach negative 8. In fact, 2 to no power equals 0 even. They're never going to reach 0. So this sort of log is impossible. And so the point is, this thing here, which is called the argument of the log, what you take the log of, has to be positive. And so that's the sort of restriction we're working with in logs. The argument has to be a positive number. Okay? And, we can sort of summarize that up by saying, if you take a positive number to any power, you're going to get a positive number. So the argument of a log has to be positive.